Textbook? No. Yes. Yes or no? Those are online. Are you able to see my screen?
Yes, sir.
Okay. See, thing is, just wanted to tell you why I'm starting with this. Because I dropped a message yesterday. No? I sent a message yesterday in the group stating I'll start with the integrals. No. The reason is because most of you have learned matrices, right? I felt like it is the same thing that is getting repeated again. I think I'm assuming you would have already solved those NCERT problems and everything, and most of you have written a test in the school also. Okay. But for those who have not learned it from school or from anywhere, for them, what I'll do is I'll give a recorded version, but give me some time. Okay. So I already have a previous recording, but I'm like the audio is not that clear. So I'll do a better recording and give it to you by this weekend. For those who have not learned, I'm telling this. Is there anyone who has not learned that chapter? May know? Those who are online, can someone tell me if you have not learned it?
Sir, I have not learned it.
You are?
I have not done it, sir.
Hari Raghava?
Sanjay, sir.
Sanjay. Yeah. I told you yesterday, no, for you I'll do it. But apart from that, is there anyone else? Is there anyone else who has not learned this chapter? May I know about others? So Hariharan,
Just started it, sir.
you have learned?
My school now only they started it, sir. Like 2
They have
exercises.
started. Okay. So don't worry. For you all, I'll record a video and give it. Right. It will be easy only. There is nothing much that you need the chapter to be taught only in the class. Okay. So please give me some time for that. I'll record and give you. Is that clear? So for now, concentrate on the next important chapter in your calculus, which is integrals. I'm assuming nobody has learned this, right? Except in maybe in physics. Physics, you would have learned the outline, but I'll teach you. Right. So shall we get started? Just give me a minute. Okay, my voice will be little loud. I'm not well. So another, if possible, you guys can come front now. Am I audible first of all? Okay, I'll try my best to project it, but see. Shall we get started? So listen. So the next chapter that we are going to see is called as integrals, right? So integrals also forms a part of a branch of mathematics called as calculus. So basically in calculus, you have two main operations. What are they? One is differentiation and the second is called as integration, right? Now, the question is, we have learned differentiation. So how to integrate things is what we are going to see in this chapter. First of all, we need to know the other name for integrals. It is also called as antiderivative. So why it's called as antiderivative is because if there is a function that is given to you, if you differentiate that function, right? So what happens if I have a function and if you differentiate it, what will you get? You will get the derivative. Okay. So generally, when you differentiate a function, you get a derivative. Derivative will also be a function. Am I clear with this? Right. Now, if you take this derivative and integrate it, you will get back the original function. So this is the simplest operation between these two operations. Is that point clear? So if you differentiate a function, you get a derivative. If you integrate the derivative, you will get back the function itself. That is why we also call this as antiderivative. So in this chapter, what we are going to mainly see is like how you learned continuity and differentiability and also applications of derivatives, right? Here we'll be seeing two things. This chapter will be understanding how to handle the tool. You can come here. In this chapter, we'll see how to handle the tool called integrals, right? So we'll basically learn about an operation called as integration, right? And in the next chapter, we'll be discussing about the concept of applications of integrals. Is that clear? So we need to know what these two are actually going to represent, right? So shall we try to understand that? So did you all make a note of this? Right. So you can just write down these keywords and that diagram. Shall I proceed? Okay. Just make a quick note. Done. Now, if you see, we told that when you differentiate a function, right? When you differentiate a function, you're going to get a derivative. See, for example, if I ask you what is derivative of sin x, you should ask that question, no? With respect to what? Derivative of sin x with respect to dx is cos x, right? So this side I'm differentiating. Now what I will do is, like how you differentiate a function with respect to a variable, right? Generally what happens if the function is y is equal to f of x, you will find dy by dx, which you also write it as f dash of x. So generally this numerator is the change in variable, right? Or sorry, the change in the dependent variable, and the denominator is the change in the independent variable. So I've already told you what is dependent and independent variable. So y is dependent on x because we are free to substitute whatever x value you want. Similarly, if I have x is equal to f of y, what will be dependent and what will be independent? X is dependent, y is independent. So what will you generally do? You will do dx divided by dy. So most of the times when you write it in this format, you always ensure that the numerator is a derivative of dependent variable, denominator is a derivative of independent variable. Is that point getting registered? Now, having said that, when I differentiate the sin x with respect to dx, I get cos x. No. So if I write d of sin x, what can I write it as? I will write it as cos x into dx. I can take the dx to the other side. Right. What I'm doing is I'm writing the derivative function as I'm writing the product of the derivative function and the change in the independent variable. Now, what I need to do is, if I need to eliminate this differential operation, I need to apply the counter operation to it, which is integration, right? Integration is basically S written like this and elongated. So it is basically called as an elongated S, right? So you put something like this, you read it as integral. It is not integration. You read it as integral of derivative of sin x is equal to integral of cos x with respect to dx. Like how you say derivative of sin x with respect to dx, here you say integral of cos x with respect to dx. This is a very, very important thing. This is what? Integral of cos x. This is a very important term to be used with respect to dx. Don't forget this. If that variable is not there, then we'll not be able to understand with which variable we are supposed to integrate. So if somebody asks you a question, what is the integral of cos x? It doesn't make sense. Integral of cos x dx is sin x. So here, if you observe, integral and derivative are counter operations of each other. Means this and this will get cancelled. Don't literally cancel them. They get cancelled in such a way that the output you are going to get is going to be sin x. This is going to be the integral of cos x with respect to x. Makes sense? Is it clear till this step? Now, see, basically, I want to just connect this concept to something else, and then I'll bring to this one. So in your statistics, you have learned about finding the average value. You know how to find the mean, right? If I give you the numbers 1, 2, 3, 4, 5, I ask you to calculate the mean of this and tell me how will you do it? 1 plus 2 plus 3 plus 4 plus 5 divided by 5, right? So if I have to write it in the form of a variable, you put this symbol called as sigma, right? The sigma represents summation. It is a summation of a variable x and you put I here. So summation of xi divided by 5. Can I write it like this? Then what do you do generally? You write I is equal to xi. This is x1, x2, x3, x4, x5. So I starts from 1 to 5. So you are adding the limits to this variable. Basically, this is summation. This is integration. Integration is also addition only, basically. But the only difference is you use this symbol when you have discrete values in your hand. When will you use it? Discrete values, meaning 1 and 2 are. So after 1, you are adding the number only 2 to it. You are not adding the numbers between them. So these two are said to be discrete values. Whereas in integration, what you will do is you will add 1 to 2. Also, you will add all the possible numbers between 1 to 2, right? Which is not possible with this because you don't have any formula for it. That is why we had to come to this concept, right? So having said that, if you just write summation, so when I write summation, I can write it without limits or with limits. In a similar way, when you write integral, you can write it without limits or with limits. So if there is integral without limits, then this is called as indefinite integral. So this operation is going to be indefinite integration because You are not sure about what is the lower limit and the upper limit. Whereas to the same integral, if you write the limits like this, then this becomes definite integral, because definite means what you're sure about. You're sure about you're integrating between which 2 points. Is the point clear? So I told you in the beginning itself, what did I say? After we learn the tool of integrals, we'll apply it in the next chapter called as applications of integrals. In applications of integrals, what we are going to do is we'll always find only the definite integrals, because definite integral has a significance. So I just want to ask you a question. If somebody asks you, why do you differentiate a function? By differentiating a function, what is the output you're getting? I've told you this many times. You're getting the slope of whom? The slope of tangent drawn to that curve at a particular point. In a similar way, when you do definite integration, you're going to get area. So that is why if you see in applications of integrals, the only job that we have is to find the area. You see, every question is based only on area. That is why it is applications of integrals. But for you to, even before you apply the limits, you need to know the tool of integrating. So that is why the first few exercises will be confining ourselves only to indefinite integral, and the last few exercises will concentrate on definite integrals. So that will give the lead to the next chapter. Is this point clear? Right. So now coming to this important statement, what is the difference between the output of an indefinite integral and a definite integral? This is what we need to. Okay. So, but before that, just make a note of all these things. See, if any of the points is confusing, please ask. So let me know once you're done. So before I proceed, I have some questions. The first question is, what is integration? Integration is the reverse process of differentiation. That point is registered in your mind. So when you differentiate a function, you need to mention with respect to which function you're differentiating, you get another function. On integrating the resultant function that you get, what will you get? You'll get back the original function. So that is why we took the example of derivative of sin x is cos x, and integral of cos x will be sin x. So when it comes to the concept of integration, integration is similar to the concept of summation, right? So where do we use sigma? Sigma is used when the data set that we have in our hand is discrete. If the data set is continuous, because functions are continuous, that's what we learned in continuity and differentiability. Functions are continuous. So when you have a continuous data set in your hand, you cannot use summation. That is why we have a replacement called as integration. And when it comes to the integration, basically you write an S and elongate it vertically along the axis of it. When you do that, you get, so based on the way you operate, there are two types of integrals. What are they? One is indefinite and the second is definite. Indefinite is without limits and definite is with limits. So definite has a significance. What is it? It is used to find the area. Area of what? I'll tell you when that chapter comes. So I hope it is clear till this point, right? Now, having said this, let's get started with the next point. See, listen. If I have correction, so if I have the derivative of, let's say I have derivative of x square. So what is the derivative of x square? 2x. So from here, can I parallelly write saying that the integral of 2x with respect to dx will be x square? Makes sense? Now the next question is, what is the derivative of x square plus 1? So integral of 2x dx is x square. But what did I tell you? When you differentiate this function, you're getting an integral value, right? That value, that function, when you integrate it back, you need to get back the original function. Here, what is that I'm getting? X square. But can I also write it as x square plus 1 according to this scenario? Can I write it like this? Let's come to a conclusion. Are you in agreement with this? Are you able to understand this point? Now, what is the derivative of x square plus 2x, and integral of 2x dx in this scenario will be x square plus 2. Meaning, if I differentiate multiple functions like x square plus 1, x square plus 2, so on till x square plus any constant that I add or subtract, I'm still getting the answer as 2x only. So from this, what is that I can conclude? That the integral of 2x dx can be x square plus any constant. So the meaning of it is, whenever you're doing indefinite integral, no, you're not sure of what is the function which you differentiated to get this value. Because if you see in all the cases, you're getting the same 2x by differentiating x square plus 1, x square plus 2, x square plus anything, x square plus or minus anything. So whenever you're doing indefinite integrals, the first thing is, after you get the function, you should always add or subtract a constant to it. 90%, not 90%, 100% will only add the constant. With the given values, you will be able to find what is that constant and substitute it back. So if there are no conditions given in the question, you will just write it as the function plus any constant that you want. So that is the first thing that you need to register in your mind. What is it? Whenever you're doing indefinite, whenever you're performing the operation of indefinite integration, right? Integration, then the function that you get should always have a constant added to it. Right? That is the first rule. So that is what we are going to do throughout the indefinite integrals part. Right? So I told you one thing, no? So from here, what I would like to just give you as an outline is, whenever you're doing indefinite integration, what is the output you're getting? Output is a function. So indefinite integration will always give you the output to be a function, whereas when you do definite integrals, the output will not be a function, it will be a number. It will be a number because you're going to get the area of that particular shape. Are you able to understand? This is a very, very, very important point to be observed. So whenever you're doing definite integration, you'll generally not get a function itself, you'll get a number. Right? Whereas when you do indefinite integration, you'll get a function. Is this getting registered in your mind? So just make a note of it. And an important point that you need to write here is, in indefinite integration, the output function should be added to a constant. The output function should be added to a constant. Or you can say the constant should be added to the output function. Right? right? Shall I proceed? Shall I proceed? Those are online. Are you clear?
Yes, sir.
Okay. So listen. So now we will see what are some important symbol terms and phrases and their meanings that are used in integrals chapter. So first of all, how do you read this? Integral of f of x with respect to x, right? That is the first one. This I have already told you, right? Second is, what is the name of this function f of x which is there inside the integral? F of x inside the integral is called as integrand. It's called as integrand. Okay. So what is x in the integral of f of x dx called as? It is the variable with respect to which you're doing the integration. I told you, whenever you're differentiating, you need a variable. In this case, generally, what variable is it? It is a independent variable, right? Next is integrate. So whenever they ask you or put a question saying that integrate a function, they are actually asking you to find the integral. Means you need to do this operation, right? An integral of, right? An integral of f. So if I take a function capital F such that the derivative of that function capital F dash of x is equal to f of x is there, then you call that as the integral of f. Okay. So how will you get this basically? When will the differentiation symbol go? After you integrate it. Right. So next is, what is integration? So understand integrate and integration. Integrate means you need to find the integral. Integration is a process, right? It is a process of finding the integral, right? And the constant of integration that I've already told you, to the variable that you get, to the function that you get, you need to add a constant. So you add any real number c that is considered as a constant function, because it is not, the value is not known to us unless the condition is given. So you generally call it as a constant function, which is written with capital C. Is that point clear? So this part is there in your textbook. So you can just have a look at it. Let's not waste time in making a note of it. So is this clear? Right. So with the help of this, what we'll do is, we will start with the main part of this chapter. That is, what are the functions and what are the integrals with respect to it, right? So there is no specific derivation. Whenever you want to find the derivative of a function, what do we use? Use the first law of derivatives. Limit h tends to 0, f of x plus h minus f of x divided by h. That is the first principle of derivative. But here, we don't use anything like that. We just use the reverse operation. So look at it. First side, the column is going to have derivatives, and the second side, it is going to have integrals, which are also called as antiderivatives. So first one, if you differentiate the function, what function are you going to differentiate? If you differentiate the function x power n plus 1 divided by n plus 1, what are you going to get? You will get x power n. So how is that happening? Because the derivative is going to be 1 divided by n plus 1 into x power n plus 1 means n plus 1 to the power of, sorry, n plus 1 into x to the power of n plus 1 minus 1. So what is the derivative of x power n? Nx power n minus 1, no. Right. So here, what do I have? That 1 by n plus 1 is a constant. X is the variable because that is the variable with which you are differentiating. Right. So I wrote that 1 by n plus 1 outside. So x power n plus 1 using this formula, what will I get? The power n plus 1 into x power n plus 1 minus this 1. So 1 and 1 will get cancelled. So what? And n plus 1 and n plus 1 will get cancelled. So you will be left out with x power n. That is why they wrote it as x power n. Now, what are we supposed to do for antiderivative? Take this dx to the other side. Integral of x power n dx will be equal to the function that you differentiated. So what is the function that you differentiated? X power n plus 1 by n plus 1. So to that, what are we supposed to do? You need to add a c. So here, one important point to be noted is you need to ensure that the value of n here is not equal to minus 1. Okay, n should not be equal to minus 1. If n is equal to minus 1, what will happen? It will become infinite. It will become, denominator will become 0. Overall, the value will become infinity, which is not different. Is the point clear? So this is the condition we need to note. Similarly, what is the derivative of x? 1, right? So what will be the derivative? What will be the integral of dx? So 1 into dx is there, no? So dx will go to the other side. So what will you have? X is equal to integral of dx. Is the point clear? So what is happening? Integral of dx is not constant. It is rather x plus c. Because I told you in the beginning, no, integral and derivative are counter operations of each other. They get cancelled. But don't cancel them. They get cancelled so that you will be left out with the variable that is there inside the d. So you get x plus c. Is the point clear? In a similar way, derivative of sin x is cos x. Integral of cos x will be sin x plus c. Okay. Similarly, what is the derivative of minus cos x? Derivative of minus cos x is sin x. So integral of sin x will be minus cos x plus c. This is a very, very, very important condition because in the initial problems, right, you will make a mistake of writing the derivative. So whenever you see integral of cos x, no, most of you will tend to write it as minus sin x. Remember, integral of cos x is sin x. Integral of sin x is negative of cos x. So there's a very, very, very common mistake that happens. It's not your mistake, right? But be careful. Yeah. Similarly, see, it's very simple. If you know the derivatives, then you can write down the original function, right? What is the derivative of tan x? Secant square x. So what will be the integral of secant square x? Tan x plus c, right? Similarly, what will be the next function? Derivative of negative of cot x is going to be cosecant square x because derivative of cot x is minus cosecant square x. So derivative of minus cot x is cosecant square x. So integral of cosecant square x will be minus cot x plus c. Okay. So you can make a note of this slide. It's a very big sir. ஒரு மாசம் போகும். So let me know once you're done with this slide. You're done? No, nobody. Shall I proceed?
Yes, sir.
So, what is the derivative of secant x? Secant x tan x. So, integral of secant x tan x should be equal to secant x plus c, right? Similarly, when you differentiate cosecant x, you will get minus cosecant x cot x. So, whenever you have those negative values, bring the negative into the derivative itself. So, derivative of minus cosecant x is cosecant x cot x. So, integral of cosecant x cot x will be equal to minus cosecant x plus c. Okay. The eighth one is derivative of sine inverse x. 1 by root of 1 minus x square. So, integral of 1 by root of 1 minus x square will actually be sine inverse x. So, this is where I want you to concentrate. Derivative of sine inverse x is how much? 1 by root of 1 minus x square, no? So, what is the integral of 1 by root of 1 minus x square? It is sine inverse x plus, correct? So, that's what the eighth one is telling us. Accepted? If you look at the next one, derivative of negative of cos inverse x is also 1 by root of 1 minus x square. So, here if you observe the function that is getting integrated, the integrand is what? So, it's the same, but you have two different functions. So, here it is sine inverse x minus cos inverse x. Which one should we write when a question is given? Both are right. Here there is no limit, no. Here we are discussing only about indefinite. The answer is both can be written. The logic is very simple. If you go back to the concept of inverse trigonometric function, I would have explained this property. Sine inverse x plus cos inverse x is pi by 2. Remember this? Right. So can I write sine inverse x is equal to pi by 2 minus cos inverse x? Can I write it like this? So I'll take this and substitute it here. So that what will happen? The same integral of 1 by root of 1 minus x square, instead of sine inverse x, I will write it as pi by 2 minus cos inverse x plus some constant. Remember, pi by 2 is a constant, c is also a constant. The sum of two constants will be some other constant, that's it. But what is happening to the function? The function becomes minus cos inverse x plus, I can write it as plus some k. Just for your understanding. So is that point clear? Right? So whether you write this or this, it makes sense. The only thing is, if you write this, the value of constant will change. If you write this, value of constant will change. So as long as you don't know the value of constant, if you're just going to write it as c, you can write either of them. Is the point clear? So when it comes to the problem, right, I'll explain how that constant will change. So is this point getting registered? Right. In a similar way, what are the two other inverse trigonometric functions which have the similar kind of derivative? Tan inverse and cot inverse. So derivative of tan inverse is 1 by 1 plus x square. Derivative of cot inverse is minus 1 by 1 plus x square. So they both are similar. So derivative of tan inverse x is 1 by 1 plus x square. Derivative of negative of cot inverse x is 1 by 1 plus x square. So integral of 1 by 1 plus x square can be tan inverse x, or integral of 1 by 1 plus x square can be negative of cot inverse x. Is the point clear? Right? So the next is, but before that, you can just make a note from that slide. Done with this? So listen. For the 12th one, so for the 12th one, derivative of secant inverse x is equal to 1 by x into root of x square minus 1, right? So what will be the integral of 1 by x into root of x square minus 1? It will be secant inverse x. Similarly, the derivative of negative of cosecant inverse x is going to be the same function, 1 by x into root of x square minus 1. So what will be the derivative integral here? Integral of 1 by x into root of x square minus 1 is going to be minus cosecant inverse x plus c. Is the point clear? Right. The next question is, what is the derivative of e power x? E power x itself. So what should be the integral of e power x? E power x plus c. So what is the derivative of log of mod x? 1 by x. So what should be the integral of 1 by x? Log of mod x plus c. In a similar way, what is the derivative of a power x by log a? So d by dx of a power x divided by log a. So what is the derivative of a power x? So if I take log a outside, so derivative of a power x is a power x log a. Log a and log a will get cancelled. So what is that you're going to have? You're going to have a power x. So derivative of a power x by log a is equal to a power x. So what should be the integral of it? Integral of a power x dx will be a power x divided by log a. This is one other point where people get confused. Because the derivative of a power x is a power x log a, whereas the integral is a power x by log a. Right? Don't mix both. Is the point clear? So you can make a note of these points as well. Shall I proceed? So listen. Now, in example 2, right, we need to find the integral of, the first question is integral of x cube minus 1 divided by x square times dx, right? So I want you all to make a note of it. any problem related to integration, any problem, try to eliminate the denominator. So in any problem related to integration, you should always try to eliminate the denominator as far as possible. Okay. So when that is the case, integral of x cube minus 1 divided by x square is there, no? So you can write this as integral of, can I split this x cube with x square? X cube divided by x square. And can I write it as minus 1 divided by x square times dx? Right? So here what is going to happen? It will be integral of x dx, right? I'll put this in a bracket. Integral of x dx minus integral of 1 by x square dx. So what is happening is the integral is getting split to each term. So you can split it when it is having a sum or difference. When there is a plus or a minus, you can split the integration to, each term, right? So what is the integral of x dx? For this, we need to recollect this formula. What is the integral of x power n dx? It is going to be x power n plus 1 divided by n plus 1 plus c. So here, what is the power? Power is 1. So what will be the answer? This will be x square divided by 2. X power 1 plus 1 by 1 plus 1. X square by 2. For this, what we need to do is, can I write this as integral of x power minus 2 dx? What is the only value n is not supposed to take? N should not take minus 1. Other than that, it can take any value. It can take negative values also. Okay. So what is x power minus 2? X power minus 2 plus 1 divided by minus 2 plus 1 plus c. Basically, it will come out as minus 1 by x plus c, because what is the derivative of 1 by x? Derivative of 1 by x is minus 1 by x square. So integral of 1 by x square should be minus 1 by x. Okay. So here what will happen is minus is already there and you have minus 1 by x plus c. So what I'm doing is I'm combining this c and this c and writing it as some other constant c. Okay. So what should be the answer? X square by 2 plus 1 by x plus c. Is that clear? So this is how it works. Right. So let me know if we can proceed. Shall I proceed? So look at the second problem in example 2. It says find the integral of x power 2 by 3 x power 2 by 3 plus 1 times dx. So what is it going to be? Integral of x power 2 by 3 dx plus integral of 1 times dx. So what is the integral of x power 2 by 3? It is going to be x power n plus 1 by n plus 1. So 2 by 3 plus 1 is 5 by 3. So x power 5 by 3 divided by 5 by 3. So 5 is written here, 3 will come here. Did you understand? So 5 is written here, 3 will go to the numerator, plus what is going to be the derivative integral here? It is going to be plus x plus c. Is that point clear? Right. So the next question is integral of x power 3 by 2 plus 2 times e power x minus 1 by x times dx. So what will happen here is it is going to be integral of x power 3 by 2 times dx plus 2 into integral of e power x dx minus integral of 1 by x dx. So what is the integral of x power 3 by 2? X power 3 by 2. So 3 by 2 plus 1 is 5 by 2. So it will be x power 5 by 2 divided by 5 by 2. So 5 will come here, 2 will come here. Okay. Plus 2 into integral of e power x. It is e power x minus integral of 1 by x. It is log of mod x plus c. So this will be the final result. Right. So you can just make a quick note of it. Just reminding that the value inside should always be positive. Because suppose you have, let's say 1 by see, if you have the integral of, you know how to do indefinite integrals. No? So if suppose the limit is 1 to or minus 1 to 2, integral of 1 by x dx, then what will you substitute? You will get log 2 minus log of mod of minus 1. So if that mod was not there, you will not substitute. Here with these problems, right? See, there are a few more problems that are given. We'll start with them in the next class. Okay. The exercise part I'll solve. You need not do anything. Okay. So examples also I'll start solving from the next class. It will be sine 2x by 2. I need a book. Those are online. We can wind up this.
Thank you, sir.